Every time Starship lifts off, 33 Raptor engines ignite beneath Super Heavy, generating more than 16 million pounds of thrust. That's more force than 5 Saturn V rockets combined at liftoff. But here's the part almost nobody talks about. Where does all that force actually go? Because before Starship can rise, that energy has to pass through a single hidden component, one piece of metal. If it fails, the rocket doesn't explode, it collapses. This is the thrust puck. The thrust puck sits deep inside Super Heavy, directly above the engine cluster. Its job is brutally simple and unbelievably difficult. Take the raw, violent thrust of 33 engines and spread it evenly into the booster's structure without cracking, buckling, or resonating itself apart. Each Raptor produces roughly 510,000 pounds of thrust. Multiply that by 33, and you're pushing over 16.8 million pounds force straight upward. That load doesn't enter the rocket gently. It slams into the thrust puck in milliseconds during ignition. And here's where SpaceX did something different. Instead of a traditional truss-style thrust frame, Starship uses a solid machined thrust puck that spreads force radially outward, feeding it into the 9-meter-wide stainless steel walls. This prevents dangerous point loads and allows the booster to survive not just launch, but engine failures. If a Raptor shuts down mid-flight, thrust becomes uneven. The puck absorbs that imbalance, redistributes the force, and keeps the rocket flying. That capability isn't software, it's structural. Now here's the cliffhanger. The thrust puck isn't just built for today's Starship. It's designed for future thrust increases, potentially pushing past 20 million pounds of thrust as Raptor evolves. That means this single component is quietly shaping Starship V2 and what comes after. And the payoff? Without the thrust puck, rapid reuse, engine-out capability, and Mars-class launches simply don't happen. It's one of the most important pieces of Starship, and you never see it. So next time you watch Super Heavy clear the tower, remember, the entire vehicle is riding on a hidden disk of metal doing the hardest job on the rocket. If you enjoyed this breakdown, don't forget to like, subscribe, and share, and follow Rocketry on Facebook, because here we break down the real engineering that makes spaceflight possible. And if you want the full deep dive into how Starship's thrust puck handles millions of pounds of force, click the link below. Because in rocketry, the most important engineering is usually the part you never see.